Hello, this is Algebra 1, Notes 9-4 on solving quadratics by factoring by Mrs. Moslick. Let's do two review problems, starting with the first one, factor. First step of factoring is ask yourself, is it in standard form? Yes, this is in standard form. X squared is first, then the x, then the number. Second step, can I take out a greatest common factor? In this case, I cannot. Then third step of factoring, ask how many terms there are. There are 3, and the leading coefficient is 1. So this is good. This is just a double bubble problem, meaning I'm looking for two numbers that multiply to get 60 and add to get 16. So let's write down our factors, unless you can think of that pair right away. You could say -1 and -60, but I'm just going to go with the positives because they have to add to get a positive 16. So 1 and 60. We have 2 and 30. You can keep using your calculator if you have a hard time with your arithmetic facts. Put in your calculator 60 divided by 3, you get 20. 60 divided by 4, you get 15. 60 divided by 5 is 12. 60 divided by 6 is 10. 60 divided by 7 is not an integer. 60 divided by 8 is not an integer. So we're going to stop there. And we already know that the pair that adds to get that middle term, 16, is 6 and 10. So we are done with this answer. However, we are not done with the entire problem. This is my final answer. My final problem work has to include the check. So we will rewrite our final answer, which we circled, and we're going to show some work here for checking. So I'll distribute the x, and then we'll distribute this 6. So let's go ahead and multiply. X times x is x squared. X times 10 is 10x. 6 times x is plus 6x, and 6 times 10 is 60. Now we're going to add like terms. So we have an x squared plus 16x plus 60, and that is what we started with, so check, we are good. Example 2, the review problem, factor. First step of factoring, is it in standard form? Yes, x squared first, then x, and the number. Second question for factoring, can I take out a greatest common factor? Well, it looks like I could divide each piece by 4. So in your calculator, if you don't know, 44 divided by 4 is 11. 72 divided by 4 is 18. So I can take out the greatest common factor of 4. So we have 4 times the quantity x squared minus 11x plus 18. Now we're going to keep the 4 out in front, but we are now going to understand that what we have inside the parentheses is a trinomial. Leading coefficient is 1. So we're looking for two numbers that multiply to get 18 and add to get -11. Let's go ahead and put our pairs off to the side. We have -1 and -8. I'm taking all pairs that are negatives because they have to multiply to get a positive but add to get a negative. -2 and -9, -3 and -6. And the pair that add to get -11 is this -2 and -9. So we have our final answer, x minus 2x minus 9. And again, the order of your factors does not matter. I could have the x minus 9 first and the x minus 2. We will we will check our answer. So write down the word check, rewrite it, and we can only multiply 2 items at a time. So let's multiply by the parentheses first, and so let's distribute by the x, and then we'll distribute by the -2. So x times x is x squared. X times -9 is -9x. And -2 times x is -2x. And -2 times -9 is positive 18. We'll add like terms. So we're left with a 4 times the quantity x squared minus 11x plus 18. Finally, we're going to distribute by the 4. And again, feel free to use your calculator if you have problems with your arithmetic. I get 4x squared minus 44x, and 4 times 18 is indeed 72, and that's what we started with, so we are good to go. Okay, in this lesson 9.4, we're going to solve quadratics by factoring. And so just to let you know, we have factored quadratics before, but now we're going to actually solve. We're going to find out what that means is we're going to take a quadratic. Now, a quadratic is just a parabola, and a parabola could be going up or down if we're talking about like y equals x squared of some sort. And where the parabola hits the x-axis are your solutions to that quadratic. And so we'll get into this later on this chapter, but right now we are just going to factor to figure out what those x values are where our parabolas hit the graph. You don't have to understand this right now. All you have to know is the steps for solving a quadratic by factoring. First step, the equation has to equal 0. Then make sure that you factor that quadratic, so make sure it's in standard form, then take out the greatest common factor, factor it completely, and then set each factor equal to 0 and solve for the variable in both or all equations. What we are doing right now is we're going to be using the zero product property. If 2 or 3 things or more multiply to get 0, one of those items has to equal 0. So for instance, if A times B equals 0, then A equals 0 or B equals 0. Or for instance, this example, if I have 2 pairs of parentheses multiplied to equal 0, then one of those things has to equal 0. They could both, but at least one of those has to equal 0. So let's go ahead and try example 1. Okay, we have a factored equation equaling 0. So we're going to use a zero product property. Each factor could equal 0. If we have a product equaling 0, one of those has to equal 0. Either the first thing could equal 0, or the second quantity could equal 0, or they both could equal 0. This is a great exercise in first semester solving. So I'm using the railroad track method. You don't have to, but I am going to keep the left side on the left side of the equation, the right on the right side. First step, we are going to subtract 1 from both sides. Second step, we are going to divide both sides by 4, and our final answer is x is by itself on the left side equaling negative 1/4. Next equation, railroad tracks, I'm going to add 2 to both sides. So our final answer here is x equals 2. So these are our answers, but for all these problems, we can check. So check. We're going to rewrite the first equation, which is 0 equals the quantity 4x plus 1 times the quantity x minus 2. So I'm just rewriting the first equation. And now I'm going to replace the x with negative 1/4. And this should equal 0. Now I don't have to do the entire quantity, but do you see I have a negative 1 plus 1, which is just a 0 in that first pair of parentheses, and 0 times anything is 0. So we do know that this quantity is on the right side equals 0. So yes, the x equals negative 1/4 does work. Check. Now let's check this next one, and so I'm going to rewrite the first equation, 0 equals 4x plus 1 times the quantity x minus 2. Now we're going to replace all of our x's with 2. So 4 times 2 plus 1, and then 2 minus 2. Now we know 2 minus 2 is 0, so I don't even care what this quantity is. It's 4 times 2 is 8, 8 plus 1 is 9. I don't have to simplify that. I just know that the second quantity is 0, and 0 times anything is 0. So that works also. So we now know we have 2 answers for this solution. We have x equals negative 1/4 and x equals 2. I'm going to pause here right now and just give you a heads up of what we're going to see later on in this chapter. This is fun stuff. You guys know how to graph, or you should know how to graph an equation of a line. But now we're going to get into graphing a parabola. And so like here, this is my x and y axis. Again, this is not for this lesson. So this is just a heads up of what's coming up. What we just found are the two solutions. When this quadratic equals 0, x is -4 and x is 2. So I'm just making a quick sketch. So the original equation is a parabola, just this, if this was equaling y. And where that equation equals 0 is where it hits on the x-axis. So it's a quick way to find out how to graph a parabola without using a graphing calculator like Desmos. But this is fun stuff to look forward to. You do not have to understand or know how to graph it yet. Example 2. This is already factored, it equals 0, so we can use the zero product property. If two or more things multiply to get 0, one of those things has to equal 0. So we're going to set each factor equal to 0. 3 equals 0, 2x minus 7 equals 0, and x minus 4 equals 0. So one of those things has to equal 0. Either the first thing equals 0, or the second thing equals 0, or the last thing equals 0, or 2 or 3 of them. Now, you guys can look at this and say 3 does not equal 0, so that does not give us a solution. You will find out that the 3 in this equation just makes the parabola more narrow. It does not affect the solutions or where the graph hits the x-axis. Again, that's going to be coming up later on, but that's just a heads up for you guys. Now, we have two equations that we're going to solve. And we're going to just solve by using railroad tracks. You don't have to use the railroad track method, but I think it's a lot easier for organization for most students. So x equals 7/2 is one of our answers, and the other one, adding 4 to both sides, we have x equals 4. So we have two answers here. Again, think about what that means. You don't have to know this yet, but just, this is just a heads up. This is kind of fun stuff. What that means is this original equation would have been, like if this was equal to y, that would have been 7/2 is 3.5, 1, 2, 3, 4. So about here. Would have been one solution and the 4 is another, so this would have been a really narrow parabola. Again, that 3 makes that narrow. But anyways, that's just what the equation would have looked like. You don't have to know that, so this is just fun stuff for now. But in this problem, we would also check, so we can check our answers, and we can rewrite our original equation. 0 equals 3 times the quantity, 2x minus 7. Times the quantity x minus 4. Replace the x's with 7/2, so 2 times 7/2 minus 7. Now you don't have to simplify this completely, but what we do want to do is make sure that one of the factors is 0. And this factor is 0 because it's 7 minus 7 is 0. And again, I don't care what 7/2 minus 4 is, I just know that 0 does equal 0. So 7/2 is an answer. Our other check, once I write down my original equation, we're going to replace all of our x's with, so we have the original equation equaling 0. Again, you can't use the zero product property unless your equation equals 0. Now we're going to replace our x's with 4. Oh, and we can easily see here that 4 minus 4 is 0, so we have an 8 minus 7. You don't have to finish that, but you do want to make sure that it is 0 equals 0, which is true. So we have two answers here, x equals 7/2 and x equals 4. Example 3, we have to factor first of all. This is in standard form. I cannot take out a greatest common factor. Leading coefficient is 1. So we're looking at the double bubble method, meaning two numbers that multiply to get 14, add to get -5, so that we will have two quantities of parentheses with an x in both of them. So let's make our number of the list. Two numbers that multiply to get -14. That would be -1 and 14. 1 and -14, -2 and 7, and 2 and -7. Now you can make that list in your head, but I prefer to write it on paper in case I mess up. We know that 2 and -7 multiply to get -14, and 2 plus -7 add to get that middle term, which is -5. So we are done with the factoring. Now, remember, we have to solve. So we needed a factor first, and now it is factored completely. The two factors multiply and equaling 0, so that means that we're going to use a zero product property. That means if two or more things multiply to get 0, one of those things has to equal 0. So the only way a product can be 0 is that one of those items, one of those terms has to equal 0. So again, I'm going to set each equal to 0. I'm going to use my railroad tracks to solve. I'll solve simultaneously because these are pretty easy equations to solve for x. So x equals -2, or x could equal 7. That's our answer. Remember, pictorially what that means is that our graph would look like at -2 and at 7, and we would have a parabola that goes through both of those. Again, you don't have to know that. That's just fun stuff coming up. Let's do a check. So write out the word check. Again, make sure you circle your answers. The answers are x equals -2 and x equals 7. Those are the x values where our equation will equal 0. So our check, rewrite 0 equals the original equation, x squared minus 5x minus 14. And in all of our x's, we're going to plug in a -2. Now, watch what you're doing with your parentheses. I have to put in parentheses for all my -2's because a -2 times -2 is +4. A -5 times -2 is +10. And we get a 14 minus 14, which is 0. Perfect. Next equation, meaning I'm just going to, as a check, I'm going to rewrite the original equation and then replace all of my x's with my other answer, which was 7. So 0 equals 7 squared minus 5 times 7 minus 14. Now note, because 7 is positive, I did not have to put the parentheses around the 7 quantity squared, but you could have. 49 minus 35 minus 14, and put that in your calculator or in your brain, you get a 0 equals 0, which is perfect. So we've checked that. Number 3 is good. Okay, example 4, first step in solving this equation, we need to factor completely. So is it in standard form? Yes. Can I take out a greatest common factor? Yes, I can take out an x, so I'm left with the x times the quantity x squared plus x minus 20. Now inside the parentheses, we're going to have a double bubble, meaning I'm going to have two pairs of parentheses, and I'm looking for two numbers that multiply to get -20 and add to get 1. So let's make our list off to the side, -1 and 20, or 1 and -20. Now one of them has to be negative because the product has to be negative. How about a -2 and 10, or 2 and -10? And then -4 and 5, or 4 and -5. The pair that multiplies to get -20 and adds to get +1 is -4 and 5. So I have a -4 and a +5. And now, since I have this completely factored equaling 0, it has to equal 0, I'm going to use the zero product property. So each factor equals 0, the first equals 0, or the second thing equals 0, or the last thing equals 0. And so again, it's important to write down the word or. If you can remember, they could all equal 0, but it doesn't have to. For instance, on that problem in one of our first examples where we had like 3 as a factor, that can't equal 0. So I am using railroad tracks here to solve. I had x equals 0 was one answer, x equals 4 is another answer, and x equals -5 will be another answer. So we have 3 answers here. Normally you could stop here, but we'll do a check. And so when you have 3, it's just a little tedious, but this is fine. Instead of rewriting the first equation, I'm just going to replace the x's with zeros right away, and you can see that each term has a 0 in it, so when you simplify the right side, you do get 0. For x equals 4, on my right side, I have a 4 cubed plus 4 squared minus 20 times 4. So I'm going to just put that right side in my calculator. I'm going to put in 4 raised to the third, and then plus 4 squared minus 20 times 4, and I get 0. So 0 equals 0. And last check, when x is negative 5, again, when you have a negative, you must use parentheses, especially when you have raised to a power. So negative 5 quantity squared, cubed, plus negative 5 quantity squared, make sure that negative's inside, and then minus 20 times negative 5. So I'm going to put that all in my calculator. In parentheses, negative 5 raised to the third, and then plus, in parentheses, negative 5 raised to the second, and then minus 20 times negative 5, enter. And you should get 0. So 0 equals 0. So that works for that one. Let's move on to number 5. This section is a great review of factoring. Number 5, we have to factor before we can solve. So first step, is it in standard form? Yes. Number 2, can I take out a greatest common factor? No. Step 3, how many terms are there? There are 3, and the leading coefficient is not 1, so we're going to do a crisscross split the middle term. So I'm looking for 2 numbers that multiply to get the first times the last term. So that's a 36x squared. And then I'm looking for those 2 numbers that multiply to get that 36x squared, but add to get this negative 15x. So what I'm going to do off to the side is make my list of factors of 36. Now they have to multiply to get positive 36, but add to get negative 15. So they're both going to be negative. So negative 1 and negative 36. Negative 2 and negative 18. Again, in your calculator, feel free to just put in 36 divided by 1, 36 divided by 2, 36 divided by 3 is 12. So negative 3 times negative 12. 36 divided by 4 is 9. So negative 4 and negative 9. Ooh, this is having a hard time writing. And 36 divided by 5 is not an integer, and 36 divided by 6 is 6. So I'm looking at all the factors of 36. Both are going to be negatives, and I'm looking at the pair that adds to get this negative 15. The pair that adds to get negative 15 is negative 3 and negative 12. So we'll put that here, negative 3x and negative 12x. You can either write it as negative 12x first or negative 3x first. Now we are ready to split the middle term. So we've just done our crisscross. Now we're going to split the middle term. So we have 0 equals 2x squared stays as is. Minus 15x is the same thing as what's in our other rectangle. So minus 3x minus 12x and then plus 18. We're going to now factor by grouping. Take the first 2 and take the second 2. We are going to factor out what's in common of the first 2. So I'm going to take out a and x. So I'm left with 2x minus 3. In our second pair, I can take out a 6, but be very careful. Take out a negative 6 because our leading coefficient inside the parentheses has to be a positive. So it has to be a positive 2. So we'll have factor out the negative 6. And you can see that whenever we're doing a problem like this, crisscross split the middle term, and you're factoring by grouping, the 2 groups of numbers, in parentheses have to be the same. So now we're ready to factor out what's in common with these 2 terms. We have 2 terms, this first term and this second term. They both have a 2x minus 3 that we can take out. So what's left of the first term is x. What's left of the second term is minus 6. So in the previous chapter, chapter 8, you were done with the problem because you just had a factor. Now we are solving. So we can use the zero product property. We have a product equaling 0. So we're going to set each factor equal to 0. So either the first factor can equal 0 or the second factor equals 0. And we'll use our railroad track. We get 2x equals 3, divide both sides by 2, and our final answer is x equals 3 halves. If you are still confused, I would rewind this And watch this over again. Maybe you're having problems with factoring. Maybe you're having problems with first semester solving for X. Whatever the case is, review and rewind this and watch this again. If that's still confusing to you, please set up a Google Meet with Miss Shalmowski or Miss Hazley or me, Mrs. Moslick. We'll be happy to work with you guys. Now, you would check your answer if you have space. I think we have space, so I'm going to do the checking way over here. Again, you always want to write it as check so that we know what we're dealing with. And we're going to check both answers. So I'm looking at the original equation, and in terms of x, I'm plugging in the 3/2. And note I'm using parentheses. And then we're going to use our calculator because you don't have to do this all in your head. So I'm going to put in my calculator. 2 times parentheses 3 divided by 2 close parentheses squared minus, oopsie, something's wrong with my calculator, so squared, and then minus 15 times 3 divided by 2, and then plus 18. Enter. You should get 0. If you didn't get 0, you just did something wrong in your calculator. Feel free to do that again. Then we will check our 6. So we have 0 equals, looking at our original equation, 2x squared, but instead of x, we're going to plug in the 6, minus 15 times 6, and then plus 18. So again, in my calculator, I'll put in 2 times 6 squared, minus 15 times 6, plus 18. So no need to write out in steps, just put it all in your calculator, and again, I get 0 equals 0. We just have one more problem to do, and the next problem is actually pretty easy. Number 5 is the toughest because we had to do the crisscross with the middle term. Hopefully this was helpful in reviewing those steps of factoring. Okay, we're going to solve. The first thing of solving is you want to make sure that it all equals 0, so we have to add 49 to both sides, and then we'll solve. So what we're going to have, we're going to factor and then solve. So x squared plus 14x plus 49 equals 0. Now we can factor. Factoring steps are, is it in standard form? Yes. Second question, can I take out a greatest common factor? I cannot. Third step, it's a trinomial and the leading coefficient is 1. So we have our double bubble, or we have 2 pairs of parentheses with an x in each. We're looking for 2 numbers that multiply to get 49, add to get 14. So 2 numbers that multiply to get 49 are 1 and 49, or 7 and 7. And 7 and 7 is our winning pair because they multiply to get 49 and add to get 14. So we can now use the zero product property. 2 or more things multiply to get 0, so set each factor equal to 0. And note that we have the same factor. So you only have to solve one of them because it's the same thing. But I'll show you that you do get the same thing. For both of these, you get x equals -7. So you only have to circle one pair. But just to give you a big picture of what's going to happen later on, that is that in our graph, this is the 0 is -7, so that means that it is going to hit the graph just at one place. That's called a multiplicity of 2. X equals -7 with a multiplicity of 2. You don't have to know that now, it's just kind of fun. But anyways, our answer is x equals -7, again, with a multiplicity of 2, but you do not have to write that. You would write that like in an Algebra 2 class. But we will check our answer, and we only have to check one answer because we only have one solution. And so you can think about or rewrite the first equation, and in for x, we're going to replace the x with -7. So -7 quantity squared plus 14 times -7, and we need to figure out if that equals -49. So we get 49 minus 14 times -7 is -98, and -98 plus 49 is indeed -49. So -49 equals -49. That works. So we are done with these notes. Hopefully this was not overwhelming. This took a lot longer than normally because we checked every problem. And I give you guys a big picture of what's coming up with graphing. And again, you do not have to graph any of these. This is just a idea of what we're doing. When you're solving a quadratic or solving an equation, you are finding out where that graph would hit the x-axis. But nevertheless, all you have to do is factor, set each equal to 0, and as long as that factoring expression equals 0, you're good to go. So if you need more help, I would encourage you guys on your notes to click here for more explanation and practice problems. And then remember your Delta Math assignment 494. And if you have any questions, again, email us and set up a Google Meet, and hopefully you guys are having a great day. Weather is better, so get outside for a break if you need to, and then come back and finish the Delta Math when you can. Have a great time, and looking forward to seeing some of you guys, if not all of you, at a Google Meet session. Have a great day. Bye-bye.